I'm going to review and build this Ender-3 V2, which has been sent to me in a charge by Banggood. Thank you very much, Banggood, for sending this to me. So it didn't cost me anything, and it's for review. So we'll build it up and pair it up and print something and go through the whole process. So it could be a long video, we'll see, here we go. But I probably won't record the whole process of building it. I'll probably do stages and explain what I'm doing each stage or something like, because it can take a little while. So we'll get into it. So the V2's got some upgrades over the original Ender-3, and I think it's basically a bit like a Pro, Ender-3 Pro, but it's got some extra differences. It's sort of like the next generation, I suppose. That's why it's called V2. Manual, slightly crushed manual, but okay. You've got the build plate, X or Y, I don't know which one it is. Anyway, the one which goes away from you, that is wider, like it is on the Pro. Whereas the Ender-3 original one, it's quite narrow and it creates a bit of wobble in the bed. This is wider, so it should be a bit better. Here's the screen, interesting shape, looks like it goes onto the frame. So that might be a means you can probably move it somewhere else if you really want to. That might be an option. It's all injection moulded. We're actually putting some money into this, because these moulds aren't cheap. This mould here is probably like 20 grand. This mould here, probably similar, it's got money, 20, 30 grand. Yeah, it costs a lot of money to make injection moulds. We'll get the bits out, chuck them on the bench here, and I'll go from there. So that's the first layer of the box. This is the second layer of the box. Small bits in there, little toolkits and things like that, and bolts and drives and stuff like that. So it's a little bit of assembly required. Right, so I think I've got basically the bulk of the bits out. Well, I think all the important bits out at least. So the bed is currently wobbling around. These they fell off, so two really loose. And I've just done those back up a little bit, but I've got to put these back on again. I'll get those back on again, so it re-secures the bed. But you may find when you get yours that these are falling off, just from vibration during transit. So here's the hot end. It's got this nice long cable here, and also you've got to put these ones onto the Z-axis here to put all the steppers and stuff like that, mount it on there. And this also goes into the main carriage. Here's the assembly which these ribbons here will plug into, which you'll have to be mounted on. So it's going to be mounted on like that, we'll go on that way. So you've got the Z screw goes through here, which I've got sitting in this tube here. So there's the Z screw, and it comes in the sleeve so it doesn't get damaged. Because if it gets a ding on that thread, it'll chew that nut out that's on there and damage it quite substantially. Each time it goes through, it'll damage it. Then we've got these tensioners. These come with tensioners now, which is quite nice. It's a new addition. The original Ender-3 didn't have these. I think some people actually made 3D printed versions of these, and obviously then Creality realised, hey, that's a good idea. We'll do the same. We've got this pack here with another little adjustment on here. I think that's for the extruder, so you can use that on the extruder part. You manually turn it. You've got various tools and caps and hardware. Bit of filament there, probably PLA, and there's also flash drive in there with an SD card in it, stuff like that. So we'll get to that. Some more tools and stuff. Not quite sure what's in that cardboard bit yet, but obviously they give you the tools to assemble it, which is quite nice. Here is the Z-axis stepper motor, so that has the screw that goes in there and you clamp it down. Now on my original Ender-3 I found that the alignment wasn't quite right. When I actually had this installed, it wasn't quite parallel with the Z beam, right, the actual framing that came up. I measured from here and at the top, and they weren't parallel. I had to shim it a little bit or do something. I can't remember exactly what I did now, but I had to change it a little bit because it wasn't dead parallel, and it's quite an important thing. Otherwise it's trying to be a bit wonky. It's just not good. As it comes down, it will bring our angle over further. We'll see how this one is, see if it's any different now with this version. Maybe that's a little thing they've tweaked in the frames or something. And also here we've got some main beams. Is that 20 by 40 and 20 by 20 or something? I don't know what these are. What size are these? Maybe 15s. I'm not sure what the actual dimensions are on these, but there's two single ones in here, and there's two in here as well, which are the wider ones, which also go to make the frame up. So you've got the vertical ones that come across, and the top beam goes across the top. So let's get building this thing. Now obviously we do have instructions. I'm inclined not to use them. So what I actually decided to do is take this bed off, because something I noticed, which I'm not sure I like it. Just take the bed off and I'll show you what I mean. So over here, obviously you've got the heated bed and stuff like this, but that's your heating element in here. And it's attached by wires here like this, that's fine. But this part here, it moves around. See if you've got the spring tension on there, as it's moving, this is going to be constantly wiggling around. Right, and the result of that constantly wiggling around is that it's going to make these wires break. Right, that's just going to sit there. This is going to move as the bed's moving. It's going to be doing that all the time. And that's going to break these wires, it's going to make them fracture. because where you got soldering on the end, it makes the wires go quite rigid and brittle, and it actually make them break right there. So I don't like that. I'm going to do something to change this. So let's see how that turns out with that bracket. One of the modifications I did on my original Ender-3 is I put a cork back on the bottom of the hotbed. So it helped to insulate it and meant the temperature was easier to control. This worked a bit better. It did actually make a difference. So if you have an Ender-3 which is factory, like this one will be, I recommend considering that you put some corking on the back to insulate it, because it does make a difference. It does help. Keeps the bed a bit warmer, it's less power used, and then you're not emanating heat at the bottom. It just works a lot better. It's just self-adhesive, you just stick it on, it's done. It's really easy to do. You just undo those, flip the bed over, stick it on. You know, obviously you've got to poke the bolt holes. In fact, that in my case would be good for this piece, right? If I had the cork in between the two, then it would be separated away. I might get some more of that cork actually. Also, there'll be links down below for anything I've got in this video, which I mentioned. If I mention a certain thing, I may chuck a link in below. Like the cork, I'll probably chuck a link down for that so you can get straight to it and buy it. Obviously, this printer, there'll be a link down below for this. To Banggood to go and buy this printer. Any information I've got will be linked down below. Any modifications I might suggest will be linked down below. So I was actually thinking maybe I should look at the manual, right? Because this is obviously different to my existing printer in many ways, but also extremely similar. But it was about 2 years ago when I built that printer, and I'm sure I'm pretty familiar with it and know how it works and stuff like that. But right, so Ender-3 V2 version 1.3 of the manual. Right, cover page tells you about the sections. Let's try and get this out of focus. Here we go. Notes, which are really small print. Yeah, it's all pretty small stuff, isn't it? Equipment, it's all really small text in here. If you've got bad eyesight, it might be good. Anyway, it tells you all the bits you get with it. That is the Y axis. I always forget which way around it is. X is this way, Y is that way. Pits that come with it. And then it tells you how to start building it. So this is what we're going to do, is basically go through this process. And it's fairly straightforward really. You just put the Z-axis on there, build the X gantry, fit it on, and put the X beam across the top. There's actually not that much to do. Then the one thing I don't like about the V2, it's the same as the original Ender-3, is you have the cable spool, so the spool holder is on top. What happens then, you got the filament that comes around and goes into the extruder. So that part of the design still isn't very good. What I actually did on mine is I didn't mount this on the top, I mounted it on the side, which reduced the vertical print height, but it lines the filament spool up with the extruder, and it's got a nice straight path in, which works a lot better. You get all these breakages and it just prints a lot better. It makes a big difference. Really, the spool holder needs to be off to the side, not on top. So, and it tells you about the final setup, stuff like that. So, wire connections, well, that's fairly straightforward, it's all marked. So, we've got bolts here. These are M4 by 45. There's 5 in here, interestingly. We need 4. So, one is probably a spare. And we've got the 2 vertical X-axis. Now, to get these right around, one has got holes in the bottom, 2 holes like this. These go at the bottom of the left hand side. And then we've got the other one here, which has got 2 holes in the vertical X section. These go on the inside edge, facing you like this, I believe. I think those are just for the power supply mounting, but in this case it has an internal power supply. It's built into the base rather than into the vertical axis. So I don't know why it's necessary. I don't think those holes are even used, to be honest. Get one in, then we'll get the second one in. You don't tighten the bolts up until you actually really tighten a whole lot, otherwise you get misalignment. So just put the bolts in, get them about right, but don't tighten them all the way down. Wait until you've got everything assembled and then start tightening, otherwise you'll get things misaligned. That's my advice from my mechanical experience. Okay, we get them kind of there, you know, you want it sort of snug so it is kind of holding it in the right place. You know, you don't want it to be wobbling around too much, but you don't want it tight. That way you can self-align, it will be kind of right, but not completely locked in, right? So this has got a little bit of movement in there. There we go, that's kind of tight. It's kind of tight, kind of rigid, but still has a bit of movement, right? That's intentional. Once I get all the other bits on, then I'll go around and tighten it all up again and make sure it's all nice and rigid and secure properly. But initially, that's what we need to do. So let's put the other beam on. Screw holes at the bottom there. Yeah, First one in. Second one in. Then we'll do that. Again, we'll do exactly the same thing we did in the first one. We'll just get them close and get it rigid but not tight. But the same deal as, you know, alignments can be tricky, right? If these are slightly, you know, pulled one way or the other, you can try and put the top beam on, it might end up being slightly skewed, and then your whole axis is skewed. And we have all sorts of weird issues, or if these might be slightly twisted, right? Because these can twist. And if these are slightly twisted and you don't have it correctly aligned with your x-axis, you have all kinds of problems. So it's best just to leave them a little bit loose until it's all together, and then you can figure out then exactly what you need to do. So that's a little bit tight there actually, I might back it up very slightly. I'm not going to put the sensors or wiring on yet. I think I'll do that afterwards, because you got the Z-axis limit switch which goes on here, which is in this bag just here. These nuts, I don't actually like these nuts very well. They would work fine, but I prefer a different style of nuts. So we've got these, I'll show you what I'm talking about. So you have these little T-slot nuts, right? So these, you can put those through the channel. You can put it through sideways and turn it, and then it will lock in, right? You can just do it up and it will lock in place, right? Now, the reason I don't like these particular nuts is they do tend to lock onto the channel, and they will tend to get jammed in the channel. You can't move them, they'll get stuck. So if you need to make any small adjustments, you might have trouble with that. Okay, just a bit of a warning, don't over tighten them. Only do them as tight as you need to in order to get things to lock in place. If you do them any more than that, then there's a good chance that it will get stuck and you won't be able to move it. Or it'll be really hard to move, you have to hit it with a screwdriver or something to dislodge it again. But being plastic on here means it's going to tend to lock onto here anyway. It will tend to grab. Right, so you've got to put them in the channel this way, and then turn it to be that way, so it grabs on the sides of the channel. The other thing you also try doing, which is what I prefer to do really, is to actually just drop it straight on the top and try and keep them straight. Okay, so let's give it a go, see if I can do that. Sometimes you can do it, if you get them just the right tension, they'll stay straight. They will kind of self-align and stay in the right place. So in this case it's doing it. Now how high we have to set this, I don't know yet, we'll have to figure that out. So for the time being, just grab an Allen key and just put it in place just like that. Okay, that's not going to move around. That will trigger just fine. So we'll have to adjust this to once we find out exactly where the nozzle sets on against the bed, because obviously it depends on what you've got your settings on here, how much tension you've got on the springs, that sort of stuff, how flat your bed is, all that sort of things we'll get to in the end. But for now, it's mounted, we'll adjust it later. So the next bit we need to do is build the X-axis, and this has got the extra holes in it. Right, so it's got holes over here. We've also got the carriage we have to put on, so this goes on one end, so we need to bolt this onto here. So this is one of the things I didn't like so much about mine as well, is that it has a bit of potential to slop in here for this alignment, which means you can actually get some misalignment, so you have to make sure this stuff's really tight when you go to put those together. So we'll put this together anyway. Which I think before I shift this out of the way, we'll do the next bit, which is to mount the Z-axis motor. I was going to do it last. So the Z-axis motor sits on here, and it's got some countersunk cap screws which hold it on. Right now, when I did my other one, like I said, I just shimmer it a little bit. And I'm not completely sure about how rigid this is. I mean, I don't know, it seems like it's cross-bolted. It may need to be something which could benefit from a bit of tweaking in the future. Maybe shimmer it a little bit or something, put something underneath to help brace it, I don't know. I'm just sceptical about bracing across sideways with a piece of plastic. We'll see, it might be fine. I mean, it doesn't have a lot of stress on it. If it's got any wobble in it, it'll affect your accuracy. Okay, so that's how it sits, is on there, and there's the holes in those beams, which you can't quite see probably because of the lighting and stuff like that reflecting off. These will be for this. I haven't read the manual really, I've just had a quick glance through it, just for, you know, seeing which stages it recommends you do it in, and that's about it. I'm not going to go any further than that. We'll see if I can do it without reading the manual, because if I can do that, that'd be good. I don't lose the tools on full. The quickest way to do this is shove it through the hole on that, and then do this. Line that one up. The same this one as well. These aren't actually screwed in very far. Mind you, the channel's not that thick anyway, so it probably doesn't matter that much, but if they've gone right through, it would be good. Now you can actually see, just with these kind of in place, I'm just going to loosen this one slightly. You do have a little bit of movement in here, right? There's a bit of adjustment range. So again, you need to make sure that really you don't tighten this down until we've got everything together. That way you can guarantee that it's then in line. Because if I tighten this down right now, obviously the idea of countersunk is to make sure it's straight, but you could still have a bit of play in there. So even the countersunk screws, it can be off a little bit. Just for leaving it a bit loose like this, Once you get all the frame and everything together, and you've got the screw in there and it's attached to the gantry, then we can tighten it down. Then it will be at least in line in that direction. It may not be in line in this direction. So we'll see how we go. And in fact, since I've actually got this in place and the wires here, I might as well just plug the wire in. Now what I'm actually looking at is whether this can get caught on stuff with this moving, because this tends to loop up a little bit. Come around the outside of it, I'll keep it out of the way, and we'll do that with it. That seems like it makes sense, doesn't it? That keeps it well clear of all this movement and doesn't get caught. And actually, while I'm around in the back here, I should actually point this out too. There's the power supply in here, okay? Now on the old Ender-3, it was up the side, mounted up the side there, and you switch in the little plate and stuff like that. Anyway, they've mounted a new supply under here, so I don't know where that's going to go. There's a switch here for setting the voltage. For me, it's set correctly 230 volt. You need to make sure you check that switch to make sure it's set for your local voltage, otherwise you could blow it up if you got it wrong. Right, so let's start building this axis up, this x-axis. Now this beam only fits on one way, so we've got 2 bolt holes here which mount onto here, and also got the recess here for getting around that cap screw there. And the other end's different profile, that's also used for the tensioner and the other end of the gantry. So it only fits one way, so you can't really get it wrong, apart from making sure you've got this opening here over that cap screw. Yeah, there's not much meat there actually. I'm not sure I prefer it that way around. I think going the other way would have been better if they threaded these metals. You know, this is steel, right? Obviously this is cheaper to manufacture by threading the aluminium, but if threaded the steel, it would be much stronger. Anyway, they did it the other way around. So I think it's these ones we want, M4x16s. I'm guessing it's these ones, there's 5 in there, so you probably need 4 to attach it, so this where it's a little bit fiddly, so you've got to sort of thread it through here, and then bolt it onto here. You know, another reason why it should be better to do it the other way around, because then you can actually get to it really easily. Yeah, I guess it's done for ease of manufacturing, I suppose. Yeah, no, it doesn't look like it actually makes it right through to the second piece here. It's not actually threaded into the second beam. So it's only actually through one thickness of this aluminium. If you're going through 2, it'd be much stronger. Inclined to actually put bigger bolts in, to be honest. We'll do it as factory for now, but there might be something to consider doing is putting bigger bolts in and make it stronger. Another little thing that Creality should do is put these bolts, make them slightly longer. If they did like 16mm, if they did 20mm bolts, that'd be enough. 4x20 instead, because they're just not quite going through to the second section. Just that little bit longer would have been much stronger. So what I did do though is I did put holes in here so you can get in with the Allen key like this. So that's quite a nice thought, at least I thought of that part. Again, I'm just going to get it so it's taut but not loose. Alright, so it can't be so tight it doesn't move at all, because say everything has to self-align. If you try and do it all tight to start off with, then you end up with problems later on. Okay, you just want it to be rigid enough to not move too much. Those screws aren't even into the second half of that channel. See that? So that's not a good thing. They should really come through. It'd be better to have them sticking out by a couple of mil than to not go into that part at all. So 20mm would have been better. Original Ender-3 has the same issue as well. Those don't come right through to the second section, so it's like a fault which has persisted all this time. So even though I've had that printer for a couple of years, those bolts are still the same length as they were originally. So they need to be made longer really. So now we have to look at getting the hot end attached to it. Once it goes this way up, you have to make sure we don't have a twist in the cables or anything like that. That looks pretty much right there. Looks like it comes straight down, no twists. And you have to slide this on, otherwise you can't put the other end on, can we? So put it on first. And then we have to put the other end on. Now this also only fits one way for the same reasons. It's got the bolt there, so that needs to go through the recess, and it has to be in line. And to get those 2 holes lined up, it can only fit one way. So that's all fine and easy. So we'll get that bolted on. So you get one spare bolt again. It's quite nice to give you a spare one. So if you lose one, you know, drop it on the floor and it goes disappearing, which can happen. This is moving really freely. There's no real play in there. It actually looks like it's adjusted pretty well already. Sometimes you have to adjust these afterwards, but this is looking really good. So we also have to look at doing the tensioner obviously, and feeding through the belt. We've got to do that too. Those are the next things we do. So I found another little thing I'm not quite sure about was as far as if it's any good. So here's the tensioner, and it came with a little countersunk screw on one side. This side doesn't have a countersunk, so it has to go that way. You see it's got a slot in here. Now this goes on the end of the carriage. Okay, so that goes over there, which means that bolt we just took in, we'll put in, got to take back out again so we can get this in. Well, that means you've got even less depth on that bolt. So it's only going to be barely into the metal. I'm not sure I like that at all. Obviously we need some on that side to allow for that bolt to go in, but yeah, I'm not convinced that's a good idea. I mean, how far is that going to go in once it's actually in place? Can we see this on camera? Yeah, it's only, yeah, I suppose it is still through the metal, but only barely. There's the beam and there's the bolt. When it's through there, through both, you can see it's right, only just through. The thing is with bolts is that the beginning of the thread of the bolt is usually actually not the full width. You see it tapers down very slightly. Get it focused. Alright, so it's not actually using all the thread either. Yeah, I'm not happy with that. The only thing I'm not sure about is on this end here, because once this is in place you can't really get to these adjustments. You can't tighten these up very easily because the rail will be in the way. So you're probably going to put this in place, get enough tension on it so it's really hard to slip, and then align it all and then take it back off and then tighten it up and hope it doesn't move. It can be a bit tricky to get that right. Alright, so here's the belt. We've just got to thread this through the channel. Should be pretty easy to do. Run it around this end, push it through the tensioner. I'm just pushing it back out. Maybe I should have put it on there before I put the tensioner on. Well, it's being a pain to get through the tensioner, so I'm going to take the tensioner back off again because it's just too hard to do it without the tensioner being off. Oh well, one of it's probably in the manual. Probably is actually. So the reason it's hard to get through the tensioner is because the gaps on here aren't actually big enough to get the crimp through it. It won't go through. So you have to actually dismantle the tensioner in order to get the belt through it. That's fine. Once you actually know you need to do that, it's fine. You just need to do it. It's not exactly a big a deal. It's probably in the instructions which I haven't read. Right, let's just get this thing mounted on. I've already thread it through. So this goes into the channels. This is currently upside down compared to where it was before, just because that's the way I have it working right now. So let's get the bolt back in this side. That one which is a bit shorter than I'd like it to be. Get it threaded in. Just hold it and get the one on this side. Same deal. We'll get that one threaded in. Is there somewhere? There we go. Again, I'm not going to tighten this up too much, but this side can be tightened. I don't over tighten it too much, otherwise what will happen is you'll split the plastic. So what you have to do is thread these over the gantry part here, like this. Through those slots, pull it right through so it's right on that stud there. That's that side done. Now I have to thread it through the other side as well. Do the same deal. Slide under there. Through there, you've got to go around a stepper motor, otherwise it won't work. Okay, so thread it through there. Go around a stepper and back through again. And then got to get back up the channel. So this is where the tweezers come in. There we go. Then we've got to pull this tight and put it into this slot this side. Okay, so that should just go in. And that is done. Okay. We should have both pushed right over. Now it's a bit sloppy in there, but that's fine. That's what the tension is for. So you do this up and it will get tighter and take the slack out of that. You don't over tighten it, otherwise you'll end up stretching the belt. You just have to make sure it's not got too much slack, otherwise you'll get variations. So now I've started to put the beam on. Obviously I've made sure that first that this isn't twisted up and that's all nice and straight. Now I've just dropped it on and it's not aligning very well. Right, now this side here, the other side, which is kind of almost there shot, this side's looking okay. It's going to drop straight on just fine. It's got plenty of play in there. This side is not going on. Now in this case you don't want to force that. What we have to do is adjust the concentric nuts so we can offset where the wheels are. Right, obviously this one here is pulling too much, so I need to adjust that. So just like the back here, you can see there's a nut. What we have to do is turn it. So let's just try to turn it. It doesn't matter which direction you're going because this just goes round and round and round, and eventually it will loosen off enough and it will come down. Once really to catch it, basically. There we go. That's off. Alright, that's probably still a little bit too tight. Don't let it pinch in too much. You want it to be firm but not too tight. That's looking pretty good there. Now the other side is too loose. But for now we'll just drop it down like that and that's in place. Now what we can do now, we're at the point where we need to look at putting the Z screw in, that sort of stuff. But also we need to check that this beam is also tight. So this right now has a lot of wiggle in it, right? Because of multiple things, nothing's tight yet, okay? So this is moving around a little bit, this is moving around a little bit, this is moving around a little bit, right? So this end is pretty much the right tension on those rollers, this end really isn't. So if we adjust that roller for a start, that will be a help. So let's do that. But then we also need to look at the adjustment of the screws, so the actual bolts which hold it all together. See, that's already a lot more rigid just by tightening that roller there up. Now you should be able to basically grab a roller and have it just about skid. If you can't get hold of a skid by holding it, it's probably a little bit too tight. Yes, this one's slightly tighter than this one. So I think I need to go slightly more on this one. It's still a bit too loose. Yep, that'll still skid just by holding it. Okay, so that's alright. So these are nice and secure now. But what I need to do is, obviously this is now kind of aligned. The frame is kind of right. What I need to do now is look at tightening these up to get them rigid, because this should be pulled straight pretty much. Oh, actually I'll wait till I get the top beam on. It's moving nice and easy and smooth though. Get these other bolts tied up. Now this side's easy, we can do those once we can get to them. But this side we can't because they're behind the beam. Alright, so we can get to these bolts on this one, we'll tighten this side up. Because this is now basically aligned, okay? So we're where we want to be. And now we can tighten it. Be careful not to over tighten, otherwise you end up stripping out the aluminium. Which is why I prefer to actually have the threads going into the steel, because they can take a lot more. Right, so that's in place. Now say that side we can't get to because it's behind the beam. But now it's going to be kind of in the right place, still going to be pretty rigid and straight, so we can do that. We can tighten it up, lift it off and tighten it up. Alright, so we lift it off. And now we can get to them. Hopefully I didn't tip too much when I actually lifted it off the end. We'll just tighten these up slightly more, just to get a bit more rigid. We'll put it back on again, just to be sure that it's definitely straight. And just confirm it. Right, that's definitely going to be held straight now. Give it a wiggle just to make sure it's definitely going to be naturally centred. And now we'll tighten them up. Just get in there like that. Yeah, I just don't like this whole threading into aluminium thing. Aluminium's not strong. Well, not for threading anyway. It's relatively weak. I mean, to me, bolting could have been better. Sandwiched. Anyway, that's done. There we go. Perfect. It's drop straight on perfectly. So that's looking good. What we're going to do now, we'll put the Z-axis screw in, put the top beam on, and then we can start tightening everything up. And all this is about reading instructions. Got to guide this up here, so that's got to sit in there like that, and then we've got to screw this one into this hole over here in this bush. Like this. There we go. Okay, so that's in place. Now we need to make sure we're actually inside here. It's all greasy, which is good, I suppose. So we'll tighten this top screw up. If this slips at all, you're going to get Z-axis issues. So you have to make sure it's definitely nice and secure. That's in there. And that should now glide down quite nicely. Okay, that's all good. Now what I'm actually looking for here is this staying about the same distance away from my finger. Because if it goes off, then it could be slightly out of alignment. Okay, that's all the way down there at the moment. So what did that hit on? That hit on something there. It hit on the Z stop. So have I got that Z stop in the wrong place? I think I might have. So see, it's hit on here. So maybe I actually need to move this over this way, under here. So obviously I've got this completely wrong here, so that's fine. We shall lift this up again, move the Z stop in the other slot. Not a big deal. Okay, what I did there is really stupid. What I did, I put it in this slot here. It should actually be on the slot on the side slot like that instead. So not a big deal. Oh yeah, there's something going wrong. Now what I was actually looking at as well, after I lifted this off, I'll show you what I mean before I put it back down. You got the Z screw, right? This is coming out naturally in this position. That's a natural position. So this is exactly the same as my Ender-3, my original one. Where this, let's try and hold this up. The natural screw position is over here. And you can see where the actual nut is, it's offset. So it's actually pulling it over. Which means it's always trying to twist. It needs to be natural position over here. So it's actually in the wrong place really. Right, that's where it wants to sit. So I'm going to do the same thing I did in my other one and shim this motor out a little bit. Maybe if I've got bolts that will do the job. I'll have to look into that actually. But yeah, that's what I think I'll have to do, is just shim it out a little bit. So this is then not trying to twist. That's a bit of an error as well by Ender-3. By Creality, that should not be trying to pull over sideways. I can actually also verify this by measuring. Let's get something better than that. Now, use a PCB ruler, because why not? So we'll look at the gap between the two. So to the back of the thread is 20mm down the bottom there. Do it up here as close as I can. Okay, naturally sitting there. I don't know, actually, no, maybe. That's interesting then. Maybe it's the mount which is shimmed off, because that is also 20mm to the outside just there. Right? If I pull it over so it's in line with the nut. So maybe I'll give them a bit of slack there. It must be the mount at the bottom was the problem. So shimming isn't the problem, it's the mount. It's twisted off very slightly. It must just be that bottom mount, the plastic one which I said before I wasn't too comfortable with being plastic. Anyway, maybe it will relax and come back into the right place. Or I could just try adjusting the screws. Let me see if I can adjust this now. Actually, now it's got alignment, we can do that. We can tighten it a bit. Alright, so this is basically tipped over like this, which is what the issue is, it's being tipped. Which is why I measured it, just to confirm, okay? So I was getting 20mm at the top, and it's about 20mm at the bottom as well. You can't really see it from that angle, but it's 20mm to that back edge. So being straight with that screw was actually okay. But on my other one, my original Ender-3, that was actually wrong. I did measure it and it was different at the top and the bottom. It didn't actually line up, which is why I had to shim it. But this is obviously now correctly spaced, but it's tipped up slightly. So what I'm going to do is I'll loosen these screws off a little bit and re-tighten them, and then tighten these up. Maybe it will come right. Maybe it's just sitting a little bit funny or something. Let's tighten it down as it is. Maybe it will put it straight anyway. But again, countersunk screws on plastics, generally not a good idea, because it do tend to split the plastic. The plastic will relax and it will split over time. So I'm not a fan of countersunks on plastics. If it doesn't have to be mechanically sound, it's fine. But when you've got something which is mechanically stressed like this, not so much of a fan. I can get the Allen key in there. They're flying off. Okay, that needs to be nice and rigid, so let's check the other ones on top here. Make sure these are okay. Hear that? Hit move? Yeah, that might be something to do with it, eh? So we'll tighten that one back up. Could have been an alignment issue with these screws at the top. I'll lift the top back off again and we'll have a look. Let's get these nice and solid. So these ones are fine. It's a sandwiching plastic, which is okay. To a point as well. You can't do that too much tension. So that's in place now, right? Let's lift the top off again, see if it misaligns. Right, lift it off. And it's closer, but it's still slightly off. Before we're sitting much further over than that. It's better. I think I could probably live with that, so yeah. Just something to keep in mind. So now we can actually look at tightening up these rails. We'll put the top piece on, and then we'll tighten those rails up, and that should be basically mechanically done. Right, so this is the piece we've got to put on top. Sit that on there like that. Put those in there. Just get them threaded in by hand to start with. And yep, that's got a slight alignment tweak. I had to put it very slightly. Push that rail out very slightly then, just to get that line up. Fraction of a mil. But that's fine. That's why we left everything loose. But now we can tighten this up. And once this is all tight, it should all be pretty much square. We can verify this frame distance top to the bottom, just to be absolutely sure. It should be the same. It should be parallel. I mean, this should be keeping it straight anyway. Well, let's check this. And down here, pretty much parallel. I can't really see the difference between there. Even the factory mill look like it's pretty good. So those are straight, at least vertically they're parallel, which is good. So we'll tighten these top ones up tight all the way, and then we'll go underneath and tighten those bottom ones up, and that should all be pretty much aligned. What I will do actually is I'll bring the carriage down lower. Actually, I'll leave it there for I'll do the top ones, I think. No, I'll go midway in case there's any twist. It will minimise the chance of twist being a problem. Yes, I'm probably being a bit too fussy about mechanics of this thing. Having a nice, strong, rigid frame, very important, otherwise it will twist a little bit and move around a fraction or misalign. Because if this was like slightly skewed, like it wasn't a true square, it was like slightly like that, you get all kinds of issues with that. You know, it could be pretty horrendous. It's very important to make sure that everything's nice and square. And most of that you can't do a lot about because it's just how it's been machined. So if it was out of square, which you could actually measure as well, you could actually measure corner to corner and measure the squareness, that will show up in your chart then, but it's not so easy to do with a tape measure. It's a bit more precise than that really. Then we can tighten these ones up. I've dropped the carriage right down to the bottom of the frame basically. It's almost all the way down. Could go a bit further, but it's pretty close. Just to help with the alignment. And obviously being tipped on its side probably isn't helping that alignment side of it that much. I mean, it should be pretty close anyway. We already try to make sure that it's not been misaligned, which is an important part of that. By having all the carriage on there, and if not that, and the cross brace set up, that should all be pretty good actually. It shouldn't really be out of alignment. It should. The only thing could be twist. It might twist a little bit, but even that's not going to be much at all. It's going to be pretty much marginal. But you have to make sure these are nice and solid and tight, but don't strip them out. Okay, I'm using a fair bit of force on these. I don't know what the torque rating should be on these. there probably is a torque rating what they should be. Who knows what they should be. It's going to aluminium, so you know your torque ratings are somewhat reduced, but you're going into aluminium by quite a decent distance. So you go one to the other, it will put it straight, because each time you do one it will adjust tension on the other one, you see. They work together. Sweep the bottom ones again. It's looking pretty good now. I think these are done. Yep. So that's that bolted down. Right, so let's do the electrical wiring now. There's not much to do on this. So we've got the ribbon over here, so I've got to figure out which way it goes. I think I'll go in this side of it. Flex like this. So we've got the E, which is the extruder. Plug it into there. Right, so there's the extruder one plugged in. Then we've got the X, which will go into here. There we go, that's it. And then we've got another X over here, which is a 2-pin, which is the X stop, which is inside this housing here. Let's make sure that the arrows on here, which you probably can't really see, they go on that side towards the front. They only fit one way, so don't force it. That's in. Obviously, to connect up the Boonton tube, we need to put a fitting in here, and it comes with a couple. It comes with a spare nozzle and a couple of clips as well. The clips are to lock the tube so they don't actually pop back out. There's already one on this end, so it comes with a couple of those. For my Ender-3, actually printed. I printed some already. Downloaded them somewhere and printed them out. Get the light on it right. You might be able to see it. There you go. There's a 4 at the bottom. So all I've got to do is screw this in here. Alright, screw it in. Simple as that. Let's find a fitting which will tighten it up. It's probably one of these ends of the spanner. Let's try this end. Here we go. So tighten it up. It needs to be secure, but don't over tighten it. This is only brass. It could snap if you do try and put too much on. Like that, and we'll plug that in. It's in there. Now we need to get these little clips and shove that in there to stop it from moving around, which improves your print quality if you don't have one. Well, if you have one. If you don't have one, it doesn't improve your print quality. It has a negative effect to your print quality. So I'll pull this out a little bit, shove that in there, push the tube right in, and then pop it in. There we go. That holds that secure, stops it floating around. Takes a lot of that slop out of it. Doesn't take all of it out, but it will actually bed in. That's all done. That's good. So what we also do is clip this to the side here. Right, it's actually got like a little holder thing in there to run that through. Let's just check the movements. See how that looks. That looks fine. So you could cable tie it there, or even just sit in that guide like that. But it does come with cable ties to tie those things down. So this screen here, it's obviously designed to go in the slots here. I'll just loosen these nuts off, so you can put it anywhere in the slot you want, really. I think I'm going to have it quite far forward, I think. Yeah, kind of. Yeah. You could put it where you want, I suppose. If you really wanted to, you probably put it further back, as long as this cable here reaches. So what I'm going to have to do, obviously because this isn't open, that could be tricky. Actually, I'm going to pop the end off, that'd be easier. Let's do that. That is moving. You also have some blanks to put on this top channel as well, up the top here, which is currently out of shot. That cross beam goes along the top. We've got some blanks to put in there. Right, let's try and slide these in. I've loosened them off enough, hopefully. Try and get this top one popped in. Just barely enough. There we go. So I'll just slide back and let's do the bottom one here as well. Here we go. So now I should be able to tighten those up and it will be where I want it to be. Okay, so that's screwed on. Now we can slot this on because it's actually got slots, so you can just put the thing on. So we're going to put the cable on. Can I go one way? That's in. And then we get that and slide it down. And that's in place. So now we can put this little cap back on the end again. Like that, so you don't scrape your knuckles on it. And we've also got the same thing to do on the very top as well. We've got these little caps which came supplied. We pop those in there as well, just to stop you from injuring yourself on the corners of the tubing, because you don't want to do that. That would be painful. Same thing both ends. Push them in nicely. And that should be good. And that way, if you catch them, you're not going to cut yourself. Right, the last thing we've got to do is put on the spool holder. This kind of locks together. Is it a quarter turn thing? It is a quarter turn thing, so everything in thread. So that is supposed to go on the top of the frame, right? Which has the issue with then you've got the filament that comes around like this. And it's got to try and basically do a 180. And it's not good. It tends to break the filament. If it gets snagged a little bit, it'll just pull it, snap it, or get stuck. So on my one, I put it on the side over here. Now it does reduce your Z axis a little bit. It does reduce your movements. it's a bit of a trade-off. I don't print this high anyway, I don't print anything that big. The stuff I do is always small, so I'm not worried about that access being restricted over here. If it did bother you, you could probably do some modification to make it work. I don't know, you could probably put a second bracket off the top maybe, like an L bracket over here. You could probably put an L bracket on the top, put it like that instead, and that'll give you a similar kind of thing without losing the movement. I mean, if you really wanted to, you could do that. But for me, I don't care. I'm just going to stick it on the side. So this has got those little T-nut things again as well, and we'll put the bolts in like this. And let's get them started. What I have to do on this time, this is a bit trickier because we have already got the frame in place, so we can't just slide them in like we were doing before. So this time I'll have to put them in and then turn them, which is a bit fiddly, but it's not something you have to do very often, so it's not really that big a deal. So this is going to be awkward, but let's give it a go. So I have to get this loose enough to get it into the channel. It's going to do one at a time. Hopefully I can get one spun, get it locked in place, and then turn the whole bracket around. And then do the other one. Spin, you bugger. Okay, that's spun. Let's lock this up enough so it doesn't turn back. If I get the right Allen key. That's called bad preparation. Bad preparation, never good for a YouTuber. Right. So that's now in place, right? So that's not going to spin back. Now I'm going to do the top one, which I now can't spin around because it's in the way. That was a bad thought as well, wasn't it? Yeah, just loose enough just to get the top one around. Okay. Fiddly, very fiddly. Let's just turn this around so more you can see. Okay, let's pop him back out. So if I put this on before I put the top strut on, this would have been a lot easier. This is probably going to go really horribly wrong. There we go, that's in there now. And I'll drop the Allen key. That's like the worst possible timing ever. Don't fall. Let's tighten this one back up again before it falls apart. Then we'll just get the top one in, do the same kind of thing. Then we'll slide it up where I want it. And then you've got this one spun around, which you won't be able to see me do. I mean, it's quite convenient that these things can be done this way, but I'd prefer different kinds of attachments personally. Anyway, you can't see what I'm doing again. Kind of get my hand out of the way. Again, just try and get the slack out so I don't fall off. And then slide it up. And tighten up right at the very top. Again, only give it as much tension as you need. Don't over tighten them, otherwise they will get stuck and you won't be able to get them back out again. Well, not easily. That should be fine. Okay, we're just about there. So now we need to get this Z-axis stop set up, right? Obviously we just put it on initially just to get it in roughly the right place. So we basically need to get the nozzle to touch this bed and set that as Z-stop. Got a glass bed that comes with it, which is nice, which is what these clips are for here as well. Personally I use PI, like a magnetic PI sheet. So we'll see how this goes first. We might put a PI sheet on instead. So let's drop this down. Now this is, say, this bracket is currently loose. So as I bring this down, they're sitting on it. And I wind it down with a stepper. And it's pushing the bracket down with it. Now don't forget, where this actually triggers isn't where it physically stops, it's where the switch engages. Now you can hear the switch click. Basically where that switch is where it's going to stop. So we need to go down past this position that's right now, get it right down, and maybe drop it down a fraction more. So it looks like I might need to adjust these tensions on here very slightly more. As I'm doing that, it's actually twisting very slightly. So I need to look at that. Obviously you can do the fine tuning with the bed levels, but I'm just trying to get a basic point. Now, another thing I actually want to think about is how low I set this level, because these springs need to be quite well tensioned, right? Because if I do change this bed to be a standard type, rather than a glass bed, might be a PI, magnetic PI sheet, which I quite like, and they're fairly cheap and easy to replace them. I'll need to raise it a little bit, so I don't want to be messing with this switch. I just want to set this once and then use these to do any final leveling. And I also like to have a lot of spring tension. It just helps to make everything a bit more rigid and solid. It's basically clicking just as the nozzle touches. So then I do the final tuning with the spring tensions and stuff on these. Again, it doesn't need to be that tight. Okay, so there's that corner there done, and let's just check this other end here. That's pulling away, so I need to take some tension off this one. And we'll check the other corner over there. It's also a long way off. I'm just doing this by eye. Obviously when you do this properly, you put some paper underneath it and stuff like that. Now this This is a much more rigid bed, and my other one, you could do one and it'll just bend a little bit. This one's not doing that. So this other corner over here is way off as well. If I can go the right way, it'd be even better. Okay, that's just eyed up to be just shy of the nozzle. Obviously he's got this coating on here as well, which has got to come off, and it's all just roughly done right now. But flatness is looking pretty good there. Yep, that's looking pretty good. So that looks even and level. What I should do now is power it up and see if it actually turns on. Alright, so I've turned off my lights so hopefully you can see the screen a little bit better. Yeah, all the lights reflecting on it and that sort of stuff. I've got power plugged in. Let's turn it on for the first time. Do this together in case something goes bang. You never know. Okay, screen's come up. A fan is running. Cool. So far so good. Right, I'm not familiar at all with this interface, so let's figure it out. Prepare. I thought it was touchscreen. No, it's not touchscreen. That's disappointing. Touchscreen would have been nice. Oh well. And it's actually obvious to see as well when you got a selection. From this angle I can't even see which one I got selected. I can see it on camera, but that's about it. Shall I do a homing and see what happens, shall we? Prepare. Auto home. Let's do a homing and see what happens, shall we? Actually what I'm going to do is lift this up a bit. And we'll make sure it definitely goes all the way down like it's supposed to and that sort of stuff. Everything in odd positions, so it's got to find its home positions. I've adjusted this axis here very slightly. I actually loosened off a little bit, it felt a bit too tight from the factory. Shows over here. So that's going to be, it's got to move everywhere. So hopefully all the switches work, so we'll find out. Okay, that worked. That worked. Yeah, and that worked too. So all the homing worked. Excellent. Nice. So the reflections on the screen, but there you go. There's information about the firmware, version 102. 220 by 220 by 250 is its official print size. I was told to preheat for PLA, so it's heating up the nozzle, heating up the bed. I suppose we'll find out how those go. Well, there's no filament in there right now, so that doesn't really matter. So the nozzle's already up, bed's already pretty close actually, that's fairly quick. It's basically come up in the same time as the nozzle has, and that's set to 60 degrees. It's a shame it isn't touchscreen, that's what's missing. It needs a touchscreen. So you can set home offsets. Oh, you can adjust the settings as well for the preheat, so you can just choose what ones you want. That's quite nice. Right, okay, cool. So if I want to set the nozzle at say 50, or no, 70, let's do 70 shall we? And it'll cool down to 70 and hopefully get there. I don't know how about noise levels and stuff like this in the printer. I don't know how quiet it's going to be. My other Ender-3, I've done a lot of work on that one to modify it. I put dampers on the steppers originally, it's one of the first things I did, and then I've changed mainboards as well, and I've currently got the Big Tree Tech. I've got the model number now, but it's a version 2 of the one I've got in there right now. I have had the version 1.2 in there as well. They both work quite well, and that's with the touchscreen as well, so I'm going to miss a touchscreen if I use this printer. This kind of needs a touchscreen really. Should we peel this off? Oh, in a minute, we'll do it in a minute. Wait for this to come down. So it's gone down to 68. So we'll see how it recovers. So that's not too bad. It went down to 68, it's come back up to 69. So it's using PID control, that's working alright. For it to react like that. Should get exactly 70 though. There we go. So that's looking fine. Okay, I'll have to learn this menu system and figure out where things are. But yeah, it's a shame it's not a touchscreen. It's almost modelled after touchscreen. You know, these look big enough to touch. I'm just surprised it's not a touchscreen, and that's really amazing. So something else has got, unfortunately, got the bloody glare from the light. It's got a little pull-out drawer in here, and 40 bits in it. So that's quite nice. Obviously they got that idea from other people which have been printing now add-ons for the Ender-3s and making things like these little drawers that go into these parts of the machine to keep the bits in, you know, like, you know, your spare nozzles and stuff like that. Chuck all those in there. Nice. 8GB SD card it came with, that's nice. And one of the things I do like about this is that the board is mounted the other way up in this thing. I'm not sure which way this has got to go. Maybe that way, let's try it upside down. Original Ender-3, it's right at the bottom there, it's really hard to get your fingers in there to put the SD cards in now. Let's get a print menu and see what's actually on the card. Nothing. Yep, nothing on the card. So there's no examples on there, at least from here. So I need to set up something up now. Unfortunately, my original Ender-3, I've changed the nozzle size on it. I've got a 0.3 nozzle on there. This will come with a 0.4. I'm pretty sure it does anyway. So any of my current print setups I've got, which I set up my 0.3, won't work correctly on here because there's obviously the nozzle size is wrong, so you just won't print in the same way. So if I want to do an example print on this, I'm going to have to re-export a G-code on this thing and allow for a 0.4 nozzle. So I'm going to have to do all that as well. Right, so I'm just about to start doing the first print. I've just done a homing on it. Didn't have to show you that, you don't have to do a homing, don't you? So let's give it a go. This is Cable Organizer, which is using a default profile from Cura. Using the finest profile, using some orange PLA, not dried, it's just straight out by draw. It does have desiccant, but it's probably still damp. And we'll get going. I've already preheated, so we'll see how it comes out. Tuning option on here. Printing speed, nozzle temperature, bed temperature, fan speed. Is it offset? We don't know yet. Might tweak that as it starts printing. When it starts printing. Here we go. Let's see. It's all about where I've got my homing set up, like with my levels. I actually prefer to tune this based on the print quality rather than using a bit of paper. Didn't change till I actually pushed the button, so it's gone down too low now. Right, let's do that. So the very first one was printing off because it was too high. See if it will come now. I tend to squish onto the bead clock as well. So it's looking pretty good there, it's quite thin, which is exactly what I want. So I'll come back later on. Well, I've been shooting this a little bit. I've reduced the nozzle temperature a little bit because I was getting a bit of stringing and a little bit of ugliness there. So I dropped the temperature of the nozzle slightly to about 190, which is what my other printer's set to generally, maybe a little bit lower. And the fan's going flat out, 255 max, as per the profile from Cura, and it's quite noisy. I don't know whether you can hear that, but it's actually a pretty noisy fan. Compared to the other Ender-3, which I already have, you don't really notice it that much. So it's 86% done, it's getting there. This is a very slow print compared to the setups I'd normally use. I think I'd normally print this in about sort of half an hour, 40 minutes, something like that on my other Ender-3. I have quite a fast print speed on it because that's all optimised and I've been tuning it over the years. This one is obviously the base setup and it's just really conservative and, as you can see, fairly slow. This is so far been going for an hour and a half. I think it's got about 15 minutes left or so. Anyway, we should peel the screen protector off because we haven't done it yet, have we? Beautiful. That's easier to see now. I still wish it was a touchscreen. Right, looks like it's just about finished. It says 1 minute remaining, 99%. So I'll just record until it's done. Over here on the back of the bench I've got one which I printed out with my original Ender-3. This is obviously in black instead. But this was printed about 3 to 4 times faster, something like that. So we'll see. It looks, you know, the bottom's because of the bed surface it's using. Using the PEI bed on this one. So considering this doesn't have any tuning at all yet, it's just basic profile, nothing fine-tuned, nothing adjusted to allow for any slight quirks with this particular machine, that sort of stuff. And I'm actually using an Ender-3 profile, not an Ender-3 V2 profile, because that's the version of Cura I've got. So there may be some very slight differences between the two. I've got no idea. I doubt there's any real differences between the two. I mean, it still does have a different main ball in it, but the rest of it is basically the same as far as the mechanical aspects. You know, like the stepper motors are the same and sort of stuff. So I don't think any of that stuff's changed. Still zero. Said zero for a little while now, and 99%. This is definitely a nicer screen than the original Ender-3, but I do wish it was a touchscreen. It just sort of lends itself to being a touchscreen. It's just it's a bit disappointing in a way. It's nice enough, but yeah. And interestingly, this knob that's on here has actually got an illumination option. It's like a ring around it. Oh, you can see it, but that's the same knob that comes with the Big Tree Tech TFT 3.5. It's the same, looks like the same knob. And that's what's running on my Ender-3, my other one. It's one of the upgrades I did to it. Touchscreen. There's a little bit of string in there and stuff like that. So don't forget this material's not been dried, so that would help. To be honest, I've never dried my materials, never have. There's been times I thought, well, I should have done, certainly, but I've never actually done it. I usually just do things like reduce the temperatures and make things go a bit slower, add retraction, that kind of thing. So I've got no idea what the actual profile is as far as retraction goes. I don't know, it's default Cura profile, so it's taken over 2 hours so far. So normally it takes me about sort of 30 to 40 minutes to print one of these things on my other Ender-3. So that's, I've spent a lot of time tuning that one though. Runs very fast. This is also with a 0.3 nozzle instead of a 0.4. Obviously that slows it down a little bit. There we go, we're done. It's been presented. Fans have finally gone off. Because of the Kawada. So yeah, summary. So you've got a confirmation button here, cool. Heats are turned off, so they're coming down now. There's still one fan running. I'm actually surprised how much noise there is from the fans on this thing. It's very noisy. Now it's obviously got the hot end fan running still, but the other fans that were here have gone off. I'd actually like to try and figure out which ones are causing all the noise. That'd be quite interesting to find out. It's done. Let's give it a chance to cool down before I try and get the thing off the bed. Might pop off a little bit easier if I wait. Maybe. Oh, there we go. It's off. Let's have a close look. Let's turn this off, eh? No, confirm it, then we'll turn it off. It's not a touch screen, Scott. Oh dear. Right. Done. Now we'll turn it off. Right. Quiet. So let's have a close look and see what we actually got. There we go, you can see the string on there from where it started off. That's before I dropped down the nozzle temperature a little bit. And there's still a little bit in those holes and stuff like that. You can see some in there. Silver's finish. It's a bit hard to see on camera. Just try and get some profile on it so you can see the textures. Not looking too bad. I mean, there are some steps in the back here. I don't know if you can see those on camera or not. It's not easy to get it all shot, but you can just sort of see these lines across here, these little steps. So it looks like it does need a bit of tuning. And if you look at this one here though, it's also got some little lines and stuff in it. Let's say that's running much faster. Alright, so I suppose the lines are in similar places. It could be a G-code thing. I mean, it's sort of lined up with these holes here as well. Let's change the profile slightly. So, and this is as it came off the printer. This one here, all right, off the other one, and there's a little bit of string on there, not much. And obviously this one's far worse. But again, this isn't a tuned profile and it's running much slower. All right, well, it printed. I think as far as the review for this thing goes, I think I'm going to summarise it with it works out the box. You know, obviously it printed just fine. Is the result perfect? No, it could do some tuning, but that could be mostly my slicer software settings. You know, it isn't a profile for this particular machine. It's a different one. And so we've got a nice glass bed, nice texture. They come off nice and easy. The texture on the bottom of the actual item is quite nice, it's quite smooth. Obviously it has this texture on it, but it's better than the PEI texture on this one. So that's quite nice. It's noisier than my other Ender-3 as far as fan noise. Motor noise is pretty good. Now my other Ender-3, I've done lots of upgrades on that. I've done the Big Tree Tech stuff, and I've got the SKR Mini E3 version 2 in there right now. And that makes the thing basically silent apart from the fans. You don't really hear the steppers at all. This I could hear the steppers. So it is a a fairly recent silent board from Ender-3. So this is still quieter than my original Ender was, apart from the fan noise. I'm not quite sure which fan it is, or whether it's, I think it's this part cooling fan. I'm not 100% sure. I did try ramping it down, and that didn't change anything. It just didn't seem to recognise that I changed the setting for the fan. But another time I had ramped it down, it did work. So I don't know. It may just be that it's waiting until it got to a certain step in the print profile. The actual sequence it prints in. Easy to build, easy to set up, easy to get going. Pretty straightforward. I like the print bed. I like the fact you've got these extra accessories now, like the little storage drawer in the bottom here. You put all the parts in there. I like the fact you get these little bits like this where you can, wind your filament in manually with that. The adjustments, the tensioners on the rollers on these belts, although I'm not really sure how critical this really is to have tensioners. I mean, on my other Ender-3, I've only adjusted them, I think, twice since I got it. I've had the thing for a couple of years. Not a big deal. Sure, it makes it nice and easy and convenient. Necessary? Not sure. It seems nice enough. It's certainly more sturdy than my original Ender-3. This nice thick rail here, nice and robust. And the bed is also much more solid. Like my other Ender-3, this wobbles a lot. This is really rigid, so that's good. That's a huge improvement in itself, just having that. But happy with that part, which is one of the main reasons I actually chose this print, is because it's got this nice rigid piece here with a nice wider area, so it's a bit more stable. Also, the glass bed on the top also means it's dead flat. The original Ender-3 had issues with the beds being slightly bowed. Mine was quite bad. Actually, I had to try and straighten it, and that's caused me ongoing issues, and I had to allow for that, which is why I've added things like the BL Touch and stuff like that on it, or the 3D Touch, the clone one. Whether or not I need to add a 3D Touch on this thing, don't know. The board has provision for it. There is actually a socket on there for BL Touch, so there's provision on the board, but I don't have one for this machine. I may install one, but if the bed is dead flat and you can get all these adjusted nicely and it's all fairly consistent, then you don't really need one. As long as your bed's dead flat. If you've got a curved bed, then you definitely need one. But if you've got a dead flat bed like this is, and for my own testing is sort of by putting the nozzle across different spots on the bed, it is dead flat. So I'm happy enough with that. At least it's dead flat at the moment. It may bow later on. Glass is actually not solid truly. It's just a really viscous material. It's just very viscous. It does actually change over time. I won't go into that. So thanks Banggood very much for sending this to me. Really appreciate that support. If you like this printer, or you want to go and look at this, or any accessories, or any other printers, follow the links down below to go to the Banggood site through my links, because then I'll get an affiliate commission and stuff like that, and for sending them sales and what have you. So if you use those links, it certainly helps me out a lot. It helps me to get more stuff for the channel. It also helps Banggood to see that I'm driving sales to their website, which means I can get more things to review, such as this. Then you get to see more videos. It's like a win-win thing, really. I think we're done. Thanks for watching. Give us a thumbs up if you like the video. Subscribe if you're not already subscribed. There's 4 more 3D printing stuff. Check out the videos at the end. There'll be playlists around here somewhere. It's probably a 3D printing playlist, one of them. There's also stuff in there as well. So check those out. You better see my other printer and what have you. Catch you later. And I'll see you in the next video. Bye. One of the modifications I did for my original Ender-3 was I put a cork backing on the back of the hot end. Stop talking shit, Scott.